I'm M.K. Datta. I'm the professor and head of the Department of Electronics and Communication Engineering in Amity University, Noida. I'm the principal investigator of one of the projects funded by the Department of Science and Technology. You can see the objective of the project is given in this block diagram. The objective of the project is biometric-based unique key generation for authentic digital watermarking. And this is funded by Department of Science and Technology, and the research work is done by in Amity University, Noida. So the basic objective of the project is acquisition of biometric signals like the fingerprint, the palm print, or the iris image, the biometric feature, and processing of these images into some feature vectors to form suitable watermark for digital processing. So interestingly, what we will try to do here is that after acquisition of the images, this will be processed into a digital pattern which is suitable for embedding into a digital, let's say, a digital image or a digital signal, digital audio signal. And of course, after this is for doing that, there may be some transformation domains, like signal processing operations that will be done, which are going to be explained in our GUI developed. For that, we have used many transform domains and signal processing operations for that. And finally, after embedding of the watermark, this watermark signal is inverse transformed to get back into the host signal, which is having the watermark in them. And then the two important tests which are the design requirements of watermarking is that, number one, we have to test for the perceptual transparency. For the image, we would like to see that the visible property of the image is not hampered, and for the audio signals, we would like to see that the audibility and is not hampered for the audio signal. And of course, we would like to see whether the embedding is robust enough to survive the signal processing attacks or not. Now let's come over here, and you can see this is the setup. This is the setup of the work that is done. Well, let me tell you, this is the camera which is used for acquisition of the iris image, and this camera is USS 300. This is an automatic exposure control electronic shutter camera, and the camera is actually 4 times more sensitive than a normal CCD camera at 945 meter wavelength. And this works in IR infrared region, and you can see over here, this is the infrared light, IR light, which radiates illumination at IR frequency, and this will help for the subject. This will help the subject to acquire the images. So this is the stand where somebody can actually stand and adjust face to put the eye and the camera in line to adjust. And this is actually an adjustable. You can see this is an adjustable platform where the subject can put his face like this to get the eye in line with the image, and this will get captured in the software over here. So you can see an iris image which has been captured. And this will be processed to form the features, and the features will be extracted to form the digital watermark. Now, this is, you can see, this is a digital persona. This is a digital persona fingerprint scanner, and this is an optical. Fingerprint sensor, and the spatial resolution is 512 dpi, and the image grayscale resolution is 256, and the acquisition time is approximately 200 milliseconds, which works. And this is the complete setup in which we have actually done the acquisition of the images, and a GUI has been developed to process the image into a watermark and embed it into the audio signal and the image signal, and then the various experiments for carrying on the perceptual test and the signal processing test has been carried on. So the next work of the processing will be explained in the GUI-based software that is developed as part of this research work. Thank you.